All right, today we're going to talk about lines of best fit and scatter plots. Now we're going to interpret some scatter plots. We're going to talk about correlation, and we're going to use lines of best fit. Now, a scatter plot is exactly what it sounds like. A scattered plot of data, meaning we do not have a linear function here, but we do have a correlation, which we'll talk about in a second. The scatter plot shows the amount of time, X in hours, that 8 students spend on homework each week and their grade point averages in Y. What is the grade point average of a student who spends 6 hours a week on homework? So if I look week right here, all right, their grade point average is a 2.0. Now, let's take a look at this one. How many hours a week does a student have? How many hours a week does a student who has a 2.7 grade point average spend on homework? Well, here's 2, 2.5, 3. So right about here, that would be 12 hours. Now, what tends to happen to the grade point average is the number of hours spent on homework increases. So as the hourly amount of time spent on homework increases, the grade point average also increases. So the grade point average tends to increase as the weekly homework hours also increase. So as one increases, the other one does as well. And I just talked a minute ago about the word correlation. Now, a correlation is when a relationship forms between two data sets. So if you notice, we've got some data sets here. They are not linear functions, but they do resemble a straight line. Here's what we call a positive correlation. As X increases, Y increases. If this was a line, this would have a positive slope. Therefore, it's a positive correlation. Here, as X increases, Y decreases. That is a negative correlation. And if you notice, it looks like a negative slope. Now, this one, there's just points all over the place. So that means there's really no correlation. So there's no pattern here. I like to call this pattern, though, hot mess, meaning it's all over the place and doesn't really pertain to a pattern. All right, so let's look at these two. Tell whether these have a positive, negative, or no correlation. Stopping distance of an automobile. So the faster you go, the longer you need to stop. So that is a positive correlation. Now, birth month and hour of sleep, meaning what month you were born does not correlate at all to the numbers of hours you sleep. So here, there is no correlation. One does not affect the other. Well, let's talk about graphing some of these. So what we're going to do is we're going to create a line of best fit, meaning we're going to take that data and write an equation. Now, we understand that it's not going to be a perfect equation, but it is going to be close. So how are we going to do this? So we're going to make a scatter plot, so let's do this. The table shows the salaries, Y, in thousands of dollars of 5 architects and the number of X years of experience. Write an equation that models the salary as a function of the number of years of experience. Interpret the slope and y-intercept of the line. So I've got 1, 50, 2, 55, 3, 56, 4, 60, 5, 62. So I already can tell I've got a positive correlation. As X increases, Y increases. Now, can this be modeled by a line? Absolutely. Draw a line that appears to fit the data closely. there should be approximately as many points above the line as below it. So I've got 5 points here, which means I'm probably not going to have an equal number above and below, but it should be pretty close. Now, everyone's line may be a little bit different, but let's see, what do I have here? Okay, they should all be pretty darn near close. Now, is everybody's perfect? Nope, but I got 2 above and 1 below. Well, now let's talk about writing an equation. Well, what do I have? I've got some points, therefore I can use these to write an equation. Now, everyone's equation may be a bit different depending on what points you use because this is not technically a linear function. So if you use different points than I do, your answer won't be the same, but it should be close. So I'm going to pick 2 points. I'm going to do 3 and 56 and 4 and 60. Why did I pick those points? I just like those numbers, no particular reason. So the first thing I'm going to do is find slope. So m equals change in y over change in x. So I have 60 minus 56, 4 minus 3, so 4 over 1 gives me a slope of 4. Now I can use my point slope formula to write an equation of a line. So let's see, I have y minus 56 equals 4 times x minus 3. So y minus 56 equals 4x minus 12. Add 56 to both sides. Y equals 4x plus 44. So there is my equation. Now let's talk about the slope and y-intercept. What do they mean? Remember, when it says interpret, that doesn't mean just tell me what it is. The slope is 4. That doesn't explain what that means. So this means that the salaries are increasing by about $4,000 a year. Now, my y-intercept, remember, that's when x equals 0. So at 0.44, that would be a starting salary. So the starting salary is approximately $44,000. Again, if you use different points, your answer may vary just a little bit.